Okay. In this presentation, we'll be going to see about the differences between basically inspection and testing, and why do we need to do it, and who actually decides the kind of inspection or type of inspection we have to do on castings, be it finished products, in process products, whatever it is. And then the part of quality assurance and quality control in the inspection and testing, who decides what, and what is the major gap? Yes, we have been doing testing, we have been doing inspection day in, day out. As we speak, also there is inspection and testing going on. Okay, then if everything is inspected and tested as per the decision taken and the agreement, still we have some issues. And where does it arise from? So that is what we are going to know about in this major gaps section. And then how do we bridge the gaps? I'm proposing some methodology or the way to bridge gaps, and then we'll be talking of something on standardization and upgradation, the way we approach things, and most importantly, quality is not free, quality is costly, and there are ambiguous discussions on this part, but there is nothing called free here. Something always comes with cost. You add or you reduce, uh, it always has an implication over the cost. So the basic differences between the two terminologies we try to interchangeably use in foundries, but they are two different things. Looks like performing the same thing, but they are different. There is something called testing and there is something called inspection. Okay. So testing involves an evaluation. That means you check for strength, you check for hardness, you check for microstructure. That means which is closer to the functionality. That means you are going to measure the performance or the functional requirements of any component. That is what is testing. Inspection is just detection. Detection in the kind of yes, no. So it is more of an attribute kind of activity we do, and testing is more related to performance, durability, life. But inspection, as I said, it is about looking for non-conformity only. It either works with a comparison chart, say, I want 12 mm, is it 12 mm or not 12 mm? Yes, okay, yes, no. You may have some reading of or a quantum of how much no, how much yes, but still it is confirm checking for the conformance, and it is going to be mostly yes, no only. Methods used, testing involves lot of equipment, a set procedure, an acceptable procedure, universally accepted working instructions, and the way of reporting and the parameters to be tested. But inspection is more of a simple equipment, mostly visual, simple equipment, and it compares against standards. It can be a physical standard or a comparison chart, or maybe an electronic means also. And examples I mentioned, all tensile testing, elongation, hardness, impact, everything is testing. And then typically inspection is looking for surface finish of the product, verifying the dimensions, whether the aesthetic look is okay, whether the surface finish or surface defects are not available. So this is inspection. And testing talks of confirming or qualifying the product for the intended performance. Inspection shows up, yes, the quality standards are met basically, and this can be processed for further activities. So that is what is the output of an inspection and testing, and we do both at the same time parallelly or one after the other in our due process of manufacturing of castings. And what are the sources of inspection and testing? Where does this start from? Like who tells you, or where does it start? So that the source of say inspection or testing is generally from technical documents, because technical documents will talk of the specifications required and what is to be inside or should come along with the component or the part. So that becomes the major criteria, and the testing or inspection is a part of confirming the technical requirements. So that is coming out of the technical documents, and need from the customer expressed and unexpressed. So we always see the customer gives us an email, some technical documents which is written like meet this strength, meet this elongation, meet this dimension requirement, this much machining allowance is accepted, and this much surface finish is accepted. Yes, this is written, but what is not written is what he it does not tell you, but still expects from you. Say, for example, in some locations, he would have specifically mentioned, yes, the surface finish, strata level surface finish of this is accepted. But he might be expecting from you that, yes, since the entire part of the casting is from the single mold, if one area can give you better surface finish, why can you not give the same surface finish to the other area also? That may not be implied or written in the paper, written on the paper, but still this will be an unexpressed expectation from the customer and guidelines from the supplier. So customer is what? Customer is a person who buys material from you. So he would have given some norms or guidelines to do inspection or testing. The other way around, some are bought out materials. You buy from different people, and they also intend to tell you how should you test their material and how should you evaluate their material. So some are expressed by means of standards for testing, method for testing mentioned in their test certificates. Some are universally available. Say derived testing. So, for example, some people measure recovery of materials, recovery of elements from ferroalloys by adding a certain amount in the increase in value, multiplying it as percentage, and expressing it as recovery percentage. Or with respect to coating, you can the supply tells you sometimes measure the viscosity, and you can even measure the wet film thickness to check the efficiency of coating on all these processes. Some suppliers do tell, some suppliers tell you to perform the way universally it is accepted. So there also you have an expressed and unexpressed way. And some are internally developed based on the knowledge and experience. This is not what the customer has asked you or told you, or nor the supplier. So this is what you learn from your own experiences. Hey, an additional a chill wedge test. Preferably, any customer would not have told you to do a chill wedge test, and your supplier also would not have prescribed to do a chill wedge test to evaluate their material. Rather, you, on your own experience, over a period of time, you would have developed the system that yes, when I do my chill wedge test, or when I do my thermal analysis, or when I do my simulation, or when I do my sand incoming quality checks, my product is going to be okay, irrespective of somebody telling me. So that is developed based out of knowledge and experiences gained, and complaints to external bodies. This mostly uh, is kind of a repetitive test or conformance test rather than the performance test. So we have been talking about source of inspection and testing. So now you will be encircled with these kind of documents which move around you. You will be mostly using these terms, at least one term at least in your day. TPAP, technical review sheet, design records, engineering change documents, engineering approval, DFMEA or PFMEA, process flow diagrams, PFMEA, control plan, MSA studies, dimension results, laboratory reports, part submission warranty. So all, and there are some more, much more. I've picked only specifics. So these are some things which circle around you, and these contain one or other data which tells you to do an inspection or a testing. Okay, so these are the previous one are the sources who generate, and these are the means which tells you, yes, this is what to be tested, and this is what is to be inspected. So when you have all these tests or inspections required out of a casting or any finished component, so you sit down, make a plan, derive it. Yes, this is what I'm going to do, and this is what I'll be not doing it. I'll communicate this to the customer. Yes, I will be accepting this quantity and this frequency of testing. Yes. So this generally discussion happens after you go through or you do any of these documentations at the start of testing or in the process of making the castings. So now let's get into inspection and testing. Who decides the inspection and testing is first the customer, then the supplier, then the external agencies, and the organization by itself. Yes, I'll take up this testing. Who influences all these things are customer, supplier, external agencies, organization, and the person performing it. So here comes uh, the skill level or the competency level of the resource being used to perform the test. Resource, in the sense, it can be, I mentioned it as person here, so it is both resource, it is man and machine both. So the methodology you perform, the equipment or tool you use, and the person who is performing it. So this influences the testing or the output. And who performs it? Probably quality team in any company, any organization. Production team sometimes supports quality team in performing this, because there is some department called process in some of the organizations where it is an intersection between quality and production. And third party agencies, yes, do some of your tests are being outsourced. And then the customer, yes, after you perform all the conformity tests at your end before dispatch of telling that yes, this component is as per what you require, the customer also receives it and then does a similar test the way you do it to accept that yes, you have said to the same way what I have expected for. The customer also performs the test. Okay, there are so many people involved. Who is responsible for everything? It is actually everyone. So, so let us talk about the different types of tests we'll be doing it. Any foundry, any manufacturing industry will be doing a variable type and attribute type. Variable type is just numbers. It will give you 20 megapascal, it will be 30 megapascal, it will be 50 megapascal. And attribute type is yes, no. Is there a defect? Standard equation is there or not? Yes, no. Is there any shift in the casting? Yes, no. Misrun is there? Yes, no. Okay. So some type of tests on the shop floor after knockout, visual inspections are mostly attribute type. Variable types are mostly uh, with gives you numbers like strength, hardness, scratch hardness numbers, and moisture content in the green sand or yellow in your prepared sand. So all these numbers are variable type where it is the output is not going to be yes, no, it is going to be some numbers. And based on the characteristics, again, it is going to be dimensional, mechanical, metallurgical, functional. So some of other stand testing parameters also fall under metallurgical because that directly affects the functionality and property of the casting. So it is basically dimensional, mechanical, metallurgical, and functional. Functional in the sense a destructive test, which is beyond the metallurgy scope, is categorized as functional. And based on the type of test being done, you do a visual inspection. Sometimes you do destructive testing, all cut samples, sections analysis, or destructive testing. Sometimes you do non-destructive testing. And non-destructive testing includes your ultrasonic testing, your dipenetral test, magnetic particle, eddy current. So all these type of testings you do, these are non-destructive testings. And some are direct and indirect tests. So direct tests are you know a parameter to be tested, and that is the output you are going to get out of an inspection or a testing. But indirect is you are intending to get one output of the test, but that is not the direct relationship. But indirectly, you try to say, for example, you're looking for a defect and you do ultrasonic testing. You actually don't see a defect. You see some graphs, some deviation in the graphs, the peaks that show. So that is a type of indirect defect because you're not seeing a defect, but you are seeing just a change in the characteristics of the wave or the current. But rather, when you look into penetrant testing for that matter or magnetic particle inspection for that matter, those are direct tests. You have a defect, you put you're looking for the defect, and the defect exactly shows up. Here it doesn't show up, it shows up directly in a different way. So this is direct defect and indirect. So these many types of inspections and testings are being performed over every casting in foundries. So where does quality assurance and control comes into picture? So we know very well that quality assurance are the team who ensure that at any point of time the process will not give any non-conformity, or if there is any non-conformity available, then they will have a team called quality control to catch hold of that non-conformity, identify and characterize the source of the same, and then take steps in the process ensuring again that such non-conformity does not recur. That means assurance tells you that this process cannot give a non-conforming output. Quality control tells you that yes, though the process is set, I will have an intermediate step in the process looking for non-conformity. The output of quality control is yes, zero defects. Output of quality assurance is setting the process to produce zero defects. So quality control and assurance go hand in hand. So when their job ends, their job starts, and the same way vice versa. So, with respect to inspection and testing, the person who is deciding the type of test or type of inspection is QA, because the requirements are known to the QA at the start of manufacture. So they decide this is how I am going to test, or this is how I am going to inspect, and this many number of inspections I am going to do. Okay, that is decided by QA. The required resource, skill set, and competency. Yes, the type of test to be done is decided already. So how do I implement it? How do I execute it? What do I need to execute that? That is generally decided by QC, because yes, I need to do hardness check 100%. Okay, to do the hardness check, what all do I need? Having a person, having a machine, and the right person and the right machine. So all these things are decided by QC after QA. And quantum of inspection, yes. So when QA decides this test to be done and the process to be confirmed by means of testing, QC tells you that yes, I'll do the inspection or testing on these many number of comps. That means 1 in 100, 1 in 200, or 10 in 100, such that I'll ensure the process is conforming. So then feedback on the test, yes, QC provides the feedback because QC has the data and the number. That feedback is taken by QA over a period of time to monitor the same and performance, ensuring that the process is set. So all these are done meeting the requirements of the customer, which is stated in the technical documents or review documents, which we saw in the earlier slides. And the frequency of test, and again, this is decided by QA because this may be reported to the customer. Okay, we know the type of tests. We have known what is to be tested. We know how many types of tests to be done and how many number of tests to be done. Who is your end customer? What is expected out of it? Yes, everything is written, but still we have some problem. So where does the gap arise, and what is actually to be filled? Not expressing or explaining the reason behind or the science behind the need. So here the word need means the need for test or need for inspection for some conformity. Why am I doing this test? Okay, you forecasting, any customer, any buyer will ask for one tensile, one hardness, one micro, and one impact if any requirement is there. And then you might be looking for sectioning of casting, looking for some soundness check, one RT at specific locations for soundness check again, and UT on the surface, sorry, UT for subsurface defect detection, 100% penetrant testing. Okay, all these tests are required. It will be in a piece of paper on an Excel sheet asking for these tests to be done, and for the frequency. Say 1 in 10 castings you do for the PPAP batch. And then in the first production lot, 1 in 20, 1 in 30. And then when you start producing, maybe once in a year for RT, once in a year for section analysis, balance everything, one for heat. All these things will be written in paper. And yes, the foundry also accepts it. Yes, I will do all these things. Yes, they accept it. The document gets exchanged, signed, approved, and the and the foundry start producing it. Okay. But why am I doing this test? What is the significance of this particular test or this particular range? What happens if I go out of this range, slightly lower, slightly higher? It's not about I confirm, I don't confirm. Okay, if I need 170 to 230 BHN for any a typical 500 watts on grade, if I'm 168, what will go wrong? If I'm 232, what will go wrong? Is it so significant? And what is that extra two numbers or three units going to signify? Am I just going to be going by the true value or absolute value, or do I have any levels, or do I have any science behind it why this extra 2 BHN or 3 BHN cannot be accepted? So this kind of analysis, though you might not have enough time, if you do it for one casting or few castings, you can develop knowledge and then uh, employ it or horizontally deploy it to all the castings or the family of castings you make. And no proper analysis on the capabilities. Yes, for example, you need to perform some dimension inspections. You do not have the enough capability, but there is a requirement. You decide, yes, I will do it. Because there is a requirement, I will do it. But are you capable of doing it, or are you going to get this outsourced? If you are going to get this outsourced, did you have any enough source or enough person or any facility available capable enough to do what the customer asks for it, or you are going to look for that person who is capable of doing it only after getting the inquiry. So, not looking for the proper capability, but still accepting the test and oversight in the way it is performed. Yes, I have been doing hardness tests for 30 years in this foundry, and so many thousands of castings have been produced. So doing hardness test is never a big problem for me. So I'll continue to do this one. What if there is a special requirement, or what if this complaisance can give you some error in the testing, not particularly hardness, any other testing, which can which you might miss and your customer might find out, and then you may get penalized for it. Overcommitment. Yes, I sometimes my capacity of testing or my capacity of inspection is only so much, beyond which I cannot extend. I feel like just to get this order to make this casting perform well, I overdo my testing. That means for every box, I'll take a micro sample and do an analysis. Every three boxes, I'll pour a coin and do testing. May not be required. I'll put same component, one heat, I'll analyze in first shift, and then one more sample in second shift. Yes, sometimes overcommitment will reduce the quality of test or inspection performed because it gives undue pressure and thereby affecting the quality of the output. And rejecting the actual requirements. Sometimes we think that yes, if I do hardness, the strength is also going to be the same. Sometimes if I miss doing hardness, I take decision based on my tensile strength, feeling that if tensile is going to be in this range, then hardness is also going to be in this range. So I need not do hardness. I can skip doing some hardness such that I can use the same tensile and micro results to certify a component, because if these two are going to be the same, in within range, accepted range, and the third parameter by itself is going to be. It is expected to be like that, but not every time. What if that particular component of that particular lot does not meet it? So sometimes rejecting the actual requirements and not correlating between the results of inspection or testing. Yes, you have hundreds of numbers, hundreds of outputs of inspections and testing with you. Do you find any correlation? There should be a correlation because all these things are produced out of a particular set process or a standardized process. So if you are missing that correlation, then that particular process of inspection is incomplete because you are not taking any feedback. In the forthcoming slides, we'll be seeing it. So the missing thing is you do inspection, you do testing, and there is something called analysis, and there is something called feedback. The preferred way is you do all these things, you analyze the data, you take the feedback, everything is okay. That is also a feedback. Okay, yes, you should tell back to your system or the process that yes, whatever you have been doing on this component or on this particular particular manufacturing technique is good, very good. You sustain the same. You ensure that you don't deviate. That is the feedback you should get after getting all the data of okay. That means 100% conformance. But what generally people try to do, make mistake is, I do a test, I immediately take feedback. I do an inspection, I immediately take feedback. I don't analyze, because only when you start analyzing, you start looking into whether have I done the right amount of testing in the right way. So sometimes there can be aberration. Not all the tests are true, not all the tests are correct. Because every test or inspection comes with an error. There is an error in everything. So as this tells, there is no absolute measure or no absolute measurement. So whenever you skip the part of analysis, you tend to give a wrong feedback. Either you reject the wrong material or you accept a right. Sorry, you reject the right material, you accept the wrong material. So that comes into picture. So green line, the appropriate and the right route. Red line looks easy. It's a bypass route, but still it's very dangerous. You can very well get caught, not today, but later. Not expressing the complete requirements on both the sides. So this comes when both the people don't understand, as per the previous discussions we have had. Both the people, the person who is intending the test or doing the test, that means the manufacturer or the foundry, the person who is buying the casting, does not tell exactly what they want. I'll give you, there are two examples I'm discussing. There are some more examples. You would have faced this in your real life. You will feel after failing a test, telling that the customer should have told me this, I should do this. Or the buyer or the customer who is getting a casting will think that this person should have told me he would not be able to do this test at the first stage. For example, microanalysis. I'll give you, this is a simple section, a cross section. You can consider it as 30 mm. The requirement is one microanalysis in this 30 mm or a 40 mm section. There are four locations, 1, 2, 3, 4. All four will conform to the statement of requirement. One section and one microsector along the section of this particular casting or in this particular area. Which of this is correct? You take at the four, your customer will look into one and then reject your casting. If you do in one, sometimes you do at the location one, sometimes at your end you may start piling up rejections at your end. You do at four and the customer wants four, both are okay. You do at two and you do at three, and two is just closer to your riser or your you have a riser or a chill nearby, and three is clearly near an ingate somewhere, and or three does not have any gating system feature nearby. So microstructure at three will be very beautiful when compared to microstructure at two. So you may get misled. So which of the following is correct? Who is the right person to tell? Which of the following is actually representative of this particular component? Which of the following is the requirement? What does the customer want? Which of the following is convenient? So there are four questions generally arise out of any particular location specific or component specific testing. So when you are about to accept a microanalysis or accept any kind of testing, have a clarity that I am going to cut this section, and at this section from this location I'm going to analyze this area, and this is what one finite images. I'll give you one nital image, one picture HD image. These are the phases I'll be looking at. If there are, for example, some people look for carbide, some people look for steroids. If there are steroid phases available, report it as 1%, 2% as per standard. If there are no steroid, report as no steroid observed rather than not filling the column. Rather than some people try to not report when the feature is not available. Say if no steroid is present, why should I write it as no steroid present? I'll avoid writing it in my report. But it may not be accepted because sometimes the customer wants to have a same word or the terminology is what he has to use, and then just say present or not present. So this is one ambiguity any foundry will be having, and any foundry will have, and they'll have to get over this. And one more example is chemical analysis. And there has always been a dispute between manufacturers and the buyers of castings, because chemistry, you take a coin, you analyze in one spectrometer, you take the same coin, go and analyze in a different spectrometer, the results are going to be the same. And the first, the most problem creating element is carbon. Everybody knows that the carbon from spectrometer is not as reliable as the other testing techniques like combustion technique or thermal analysis technique. But still, for productivity purpose and feasibility, spectrometer is the only option available for the foundries to manufacture. So when the customer gives you, or when you intend to manufacture one grade, say for example carbon 3.4 to 3.6, it should be accepted that I will use my spectrometer of this measurement variation to certify or measure this particular range of element. So any deviations beyond this, this can be discussed and then settled. Rather than arguing, yes, my result is correct, his result is correct, both might be correct or both might be wrong, because we know what the spectrometer can do. Or if we have a practice of making an alternate way of analysis, that also to be communicated and then mutually agreed. So this is one gray area where you always get into dispute, and finally somebody has to make a compromise, and preferably or mostly it is going to be the foundry. So should be careful enough. The four same questions comes up. Which of the following is correct? Is the type of analysis representative? So these questions always should come up and then get clarified. And next missing thing is, when you look into any failure mode analysis, whatever we do or in any foundry is being done, mostly surface defects are addressed, or soundness defects are addressed. Say one blowhole, one microporosity, shift, and then you can talk of hot air, cracks, all these things are observed. But why not metallurgical parameters? Why this is generally done is because The preventive actions mentioned in FMEA will generally be what the foundry is already doing or what the foundry immediately they can do. That means whatever the facility they have, what they can immediately change or what they can immediately do. Kind of.
Hello? No voice, Mr. Veera.
Sir, Veera Vignesh, sir, your voice is low. Veera Vignesh, sir. Sir, wait a minute, sir. I think due to some network issues, he's left. We'll join within 1 minute, sir. Please, sir. Sir, our Veera Vignesh, sir, left side are plugged, sir. Oh.
Shall I speak to the speaker or phone?
So please wait for 2 minutes, sir. Speaker is on due to some network issues, sir. Speaker will join.
Sir, am I visible? Sorry for the.
Yes, sir, sir. Visible, sir. Visible, sir. You can continue, sir. Thank you.
Okay. And the other missing things, what will be the next problem, future problem is the concurrence between the way of testing between the manufacturer and the supplier. Say you perform your testing the same hardness test or the same chemistry analysis over the sample will be in one particular way, and the buyer of the casting will do the same analysis in a different way. And if these two things do not match, and you will still have the same problem, and the differences come. Complacency, yes, there is a thought that we always do is right and perfect. That will also create a problem. And not forecasting what can go wrong. So anything you do, you should also have a thought that something can go wrong, and you should have plan B or ways to correct it. Not say what can go wrong is what if you get a wrong reading or what if my method is going to be wrong. So that, and you always do some approximations and assumptions during testing, that also to be avoided, because that can give you some loss or some failures. And revisiting and updating the FMEA with any new or improved corrective actions. Any new corrective actions being taken for some other problems also, some other castings also, then FMEAs ought to be updated, because FMEA is your parent document telling that, yes, this is how I'll do the inspection. FMEAs tell you what are the additional tests I'll be doing it to ensure that the conformity is ensured. Yes, there will be hardness, tensile, all these conformity tests will be measured separately. You are going to perform them. Additional tests will be mentioned will be taken only from the FMES, because FMES still what additional test you have to do. Some defects would have come in the process. To avoid the defects, some more additional tests I'll do. So that input comes from FMEA only. So frequent updating of FMEA plays a major role. And a small error, it's course correction, not doing timely course correction. In case if you have to make some changes in the frequency or change in the way of analysis or upgrading yourself, that should be done. And missing the horizontal deployment, yes. So ask the right question and get the desired answer. You tell that this is how I'm going to inspect and this is what is going to be the output, and the loss in the output, or say for example the deviation or the variations in the results is going to be this much, and this is how I'm going to improve. I have an improvement plan. You express everything, you ask your right question, and then get the desired answer. And read between the lines of the provided technical documents and requirements. It will mention that yes, micro to be done, hardness to be done, but some more information are provided or are hidden inside those lines. You should be able to decode that or ask for it and get it understood, clarified, sorry. In any of the requirements, if any of the requirements could not be get an approved deviation, yes, for drawings, for changes, yes, there is a deviation approval, set process, everybody follows. What if there is a deviation in the testing? You know the result is, the component is okay, but the test results show that the component may get rejected. But in such cases, how do you take up and then you get that clarified and then you get that approved? Approval for deviation is not just for dimensions. Approval for deviations are for tests and inspections also. Standardization and upgradation. The idea is you don't need to replicate what your buyer would be doing it. It can be the quality of test and the quantum of test what your intended person will be doing it. And look at the every output of any foundry as a functional part or not just as a casting. Yes, you should have some not an emotional attachment, but you should know what this particular component is going to do. And if I fail to do a proper inspection or an intended inspection, what can go wrong? Why am I saying quality is costly? Need for reanalysis that increases your cost for which you would not have accounted for. Cost of rework, then reanalysis. Yes, when you do a rework, then you have to perform the same type of analysis you have done at the first stage. That is point number one is without rework, and if somebody does not believe your number, you have to prove it to them, then you have to do one more analysis. That is reanalysis. Cost of rework is yes, you have accepted the failure, you have accepted the rejections. Yes, you have a scope for rework, then you do reanalysis. That is 2 times cost. Cost of increased frequency of analysis. After you get a failure, if you are not detected or not performed the test properly, some non-conforming casting has gone to the end user and he finds it finds it as an issue, and then he reports it to you. The first thing what he would expect is, okay, increase the frequency of testing. Instead of 1 out of 100, you do 10 out of 100, or you do 50 out of 100 analysis for me. So exponential increase in frequency of analysis for which you are not prepared for. Because this change, everybody would be expecting to get implemented as the next immediate hit. You may not have the enough manpower or the resources immediately available, but you will be forced to do it. So that is costly. Introduction of new types of testing and analysis. So what happens is at the start of manufacturing, you will not have any problem. All the things are set, and because what you can test is what you have accepted. Yes, everything goes well. You suddenly get a rejection. You start listening to new types of tests and analysis, which you have not planned for already. So this inclusion of additional tests makes it costly. Many short-term corrective actions. You start taking short-term corrective actions as an output of your interview checks or tests. This will make it very costly because you have not accounted for these changes immediately. More defective testing for revalidation. The moment you have a non-conforming output, you may have to do destructive testings for validation. This again will not be accounted for at the start. This destructive testing is going to cost you more because it is not just the cost of testing, it is the cost of the component also. Any new change, as discussed, will have an additional testing. And I've come to the end of my presentation. So my last slide. So testing and inspection, yes, do play a vital role. a defined and appropriate plan to be arrived at, what is being tested and what is to be tested and what not to be done. And upgradation evolution with time to be done. I cannot, though the method is very accurate and today's fast and then increased speed of expectation, sorry, the speed at which the output is expected, the existing setup may not be useful 1 year from now, 5 years from now. So there is a need for upgradation and evolution every time. And understanding of the intended output, what is going to come out of your testing and what is being expected by the customer or the buyer should match. If not matching, then raise the flag immediately. Acceptance levels of all types of variations, this is to be discussed. For this, you should have the knowledge of what kind of variations we are generating or you are generating at your foundry at all levels of inspections and testing. Analyze and take feedback at all the stages. Even if all the testings are okay, it should be that yes, there are no issues. Feedback is to be taken at all location or all stages. And I always end up saying Tirukural because somehow I'm very much attached to that particular words because that tells you life science. It can be applied to anywhere. முடிவும் இடையூறும் முற்றியாங் எய்தும் படுபயனும் பார்த்து செயல். So I'll decode it for you very easily. What does it tell is? செயலை முடிக்கும் வகையும் வரக்கூடிய இடையூறும் முடிந்த போது கிடைக்கும் பெரும் பயனும் ஆகியவற்றை ஆராய்ந்து செய்ய வேண்டும். I'll translate it for you. செயலை முடிக்கும் வகையும், that the method of doing things, that means the way you do a test, the way you perform something. Obstacles and what can go wrong, the knowledge of what can go wrong, and முடிந்த போது கிடைக்கும் பெரும், the knowledge of the intended output. What are you going to get as an output of this action? Maybe testing, inspection, manufacturing. Should be analyzed, known, and then only performed. So you should know what this is going to, how am I going to do this, what am I going to do this, and what can go wrong, and then I should have taken them enough preventive measures and actions, and what is the intended output, and I analyze all these things, only then I start my testing. If in case I miss something, I do a course correction during my performance. So I thank you all for patiently listening to this. Technical webinar, yes, I have not touched any technical because people here are already tech experts. I don't want to continuously tell them how to do hardness test, how to do tensile test, how to do microanalysis. People here are very good experts in doing it. Okay, we do everything, but still there is a small gap. And how are we going to address it is what I'm trying to, I've tried to express it in these 40 minutes. And thank you. And over.